Okay, so everyone should have their own roller coaster paper. Make sure both of your names are on it, so yours and your partner's. We're just going to do a little example so that way you understand what exactly you're doing. So you are creating a roller coaster using a polynomial function, which we've been going over. Okay? All right, so where it says the amusement park you are designing for gave you the following roller coaster requirements. Your roller coaster must be modeled by a polynomial of at least degree of 5, which means that's the number of roots, but no more than 8, because you're going to be multiplying them together. Okay, so you have to have at least 5 roots, and the max you could have was 8 roots. The roller coaster can start at any height. The ride dives below the ground, which means it will be going in the negative y values, into a tunnel at least once, and think how this would look on the graph. Okay? All right, so this clean sheet of copy paper, we're going to be using the long either yellow or blue paper that I have out. And you won't need to be doing that until the very end, once you've finished everything. All right, so let's look at number 1. I'm going to do an example, so that way it'll help you understand what exactly you're trying to do. You're drawing a rough sketch of your roller coaster on this paper. You're using the coordinate plane. Now, I'm not going to be worried about any negative x values. We will look at some negative y values because it's going to go under or in a tunnel. It says be sure to illustrate your x and y axis to identify the length, which is going to be your time. And then, so this is going to be time, and then your height will be your y of the roller coaster. Make sure your design meets all the criteria listed above. Now, what I'm drawing right now is not going to meet the criteria above because I'm trying to do a general example so that way you understand what you're trying to do. So, I'm starting my roller coaster up here. Just say I'm starting up here. I'm going to go down. It says you have to have one point that goes through your, or goes through the tunnel, which is below the y-axis. All right, so I have a root. I'm going to say this is 2. Okay, so notice I have a double root. At 2. So once I've drawn my roller coaster, I find my roots. So it says on number 2, you're going to list all of your roots. I have a double root at 2. And notice it says here you have to include at least one double root. And then I have a root at 4 and a root at 5. Okay? Alright, so that's what you're doing. Again, your criteria up at the top, it said that you can only, or you have to have at least 5 roots and you can't exceed 8. So in between 5 and 8 is what you should have. Now, this picture on this paper is just a rough draft. It doesn't have all of your colorings, your colors, or anything like that. Okay? Just a rough sketch. Alright, so then it says it might be necessary to go back to your design and modify it according to these root requirements. So make sure that you're meeting the requirements. You're writing the complete factored form of your roller coaster. So you have a function. If I have a double root at 2, it's going to be x minus 2 squared. If I have a root at 4, that's going to be x minus 4. And then if I have a root at 5, that's going to be x minus 5. Since I have 4 roots, that means it should look like a quartic. So if it's an even power, it should look like a parabola. Now, you have to pay attention to whether it's positive or negative by the way that your roller coaster looks. Notice it's opening up on mine. See, that's here and here. It's opening up. That would be a positive, which means it needs to have a positive. So if it was opening down, if it was starting in a tunnel, then you would have to have a negative in front. So make sure that you do that. Now, once you get to number 4, you're going to have to find your equation in standard form, which means use FOIL to multiply it out. So my function in the front was x minus 2 squared, and then x minus 4, x minus 5. So right here, when it's squared, go ahead, when you have a double root, go ahead and write it twice to make it easier for you. Okay, so when you're multiplying it together, you need to multiply 2 at a time. So I would go ahead and multiply those together, get an answer. You could also go ahead and multiply these together, get an answer, and then multiply those 2 answers together. But you should be multiplying it out. It's going to be a long answer. Okay, so make sure both of you need to be doing this so that way you can see if you get the same answer. That's why you have your own paper. I'm not doing this for you. I'm just explaining it. So make sure you multiply it all out. Okay, so on 5, we're choosing one of your roots and divide it out using synthetic division. You must get a remainder of 0. So choose any root that you want. So I had a root at 2. So synthetic division, we would write it out. You're having to use your coefficients. So you're having to use the answer from number 4. Okay, so you're having to use that answer, bring it down. That should be from. So you're having to bring that down in order to figure out your coefficients. Then you can use synthetic division. You should get a remainder of 0. So pick any one of your roots. It doesn't matter which one. You're describing the end behavior of your function. So telling me what's happening at the very end of your roller coaster. Give a reason for this behavior. Explain it. What's happening. 7, draw a neat, nice picture of your roller coaster. That's the colored paper that I have for you, the long colored paper. It needs to be nice and neat. I also have examples taped on the board that you can look at. That's what I want you to do. It needs to be, you can use colors, you can use markers that I have set out for you. Now, you need to come up with a domain of your graph. The X, remember, is your time. I want the actual time of the ride. So it doesn't matter what your function is. It just matters, I want you to come up with how long is your ride lasting. 6 seconds or a minute, 2 minutes. You need to come up with that. The practical range, remember your range is the height of the roller coaster. So you need to, of the actual ride, so you need to tell me it's starting at this height and it's going to this height at the top. So you're explaining that. And then you're coloring the graph blue on your roller coaster where it's increasing, red where it's decreasing, and then you're identifying your increasing, decreasing, and constant, which means if it's staying in one spot, you can use different colors than that, but they need to be 2 separate ones and you need to label it on your actual graph. So tell me if you're using purple, purple is increasing and red is decreasing. You need to make a little chart there and tell me that. Okay? Alright, so you need to be working with your partner on this project. You're also going to have some time tomorrow, but we are going to present. So make sure that you're using class time today. I can answer any questions tomorrow. So if you get stuck on something, move on to something else. So that way you're using your time wisely, okay, and working on it. Again, if you have any questions, we'll go over that tomorrow.